Okay, these are the things I've made to control stuff around my house. It's taken about 2 years to get these built and working together, to learn how to do electronics from scratch. I use dip trace to make the boards, and then JLC PCB to fabricate them, and then I populated them myself. The boxes are also made by JLC PCB. They are MJF, which prints really nicely. It's really hard to tell that they're 3D printed. They're snap fit, so the boards fit in without any screws. Lids snap on, snap off. So the main thing is that I wanted everything wired. So I'm using these WESP32s, which is an ESP32 with power over Ethernet. And that gives me a LAN connection that's wired and up to 1 amp of current. And it gives 3.3 volts and 5 or 12 volts. So that's very convenient compared to the other PoE boards that are available. The WESP32 is pretty good. Then the daughter boards plug into that and go in the box. All right, here's the first board. So this one, it has 16 inputs, and these get wired to TechScan force sensors on the staircase. So one for each stair. That lets me know when the stairs are being stepped on, and then I can control the lights based on that. The lights are DMX, so I don't have to have that on this board. This is just for the sensors. The way it works, this section is the signal processing. There's a potentiometer and a digital potentiometer, allowing for some control of the sensitivity. So I can adjust it based on the weight of the stair itself and how much pressure is normally on the stair when it's not being pressed on, things like that. So this does the signal processing for a single stair. That's an ADC. And then this is a MUX, 16-channel MUX. So it scans one stair at a time over and over very rapidly and sends the result to the ESP32, which sends it over the LAN to my computer. So my computer is running my software to control everything in the house. And instead of using like Home Assistant or something like that. So this plugs onto the ESP32, and then there's a nice plug. It goes like this, so you can disconnect the wires without taking them all out. It's very convenient. And I have another one that is basically the same. The difference is that the MUX is 4 channels instead of 16. So this will be for 4 sensors that are in a bed. So I can tell occupancy of the bed and do things like nighttime or morning automations. But otherwise, it's exactly the same. The board is red because in the beginning, I wanted all the boards red because it looks cool. But it's a lot more expensive, like something double or more than that. For so many boards, it doesn't make sense to make them all red, especially when I didn't realize in the beginning, but I'd be remaking these boards over and over and over to fix little minor mistakes or add little features. So do yourself a favor and just make them all green from the beginning. So this next one, this has 21 reed switches. All throughout the house, there are reed switches that get wired back to this. And that lets me know when doors are open or closed throughout the house, interior, exterior doors. So these are optocouplers. So 24 volts comes in here and goes to all the switches. And then when the reed switch is closed, it turns on the optocoupler, which sends a signal to this, which is that's an IO expander. So it gives me 16 more IO pins in addition to what the ESP32 has. And that's how the signals get from the reed switches back to the computer. We also have some other things here. There's an external board for a bathroom, and that board has temperature, humidity, and VOC sensors so that it can tell smells and when it should turn the fan on or off. and the fan is turned on and off using DMX. So the computer gets the signal from this board and decides if the fan should be turned on, for how long. The computer does the actual control. This is just for sensors. So there's 3 RS-485 transceivers, and then this is a UART chip and an oscillator. And then these two, they're also serial. They're also RS-485, and this goes to AC units. So the way that works, the AC is a Mitsubishi ACs, and they have something called a Kumo Cloud connection, which connects to their cloud junk for controlling the ACs, which I obviously don't want to use. So I built this, which the Kumo Cloud connector goes here, which is 5-volt ground and 2 wires for transmit and receive for serial connection. That goes through this RS-485 chip and is powered by the 5 volts on the AC. And then it goes through Ethernet, so I can have long wires to my other boards, like this one, that connects to 2 AC units. So this RS-485 is powered by the 5 volts from the AC, and then there's optocouplers to protect my electronics from the AC. So with this, my ESP32, so therefore my computer, can control the ACs and set the temperature that we want, and it can also send the current temperature. So I don't have any thermostats in the house. Instead, I will use probably battery-operated Zigbee thermostats or temperature sensors to send the temperatures back to the computer, which will then send it to the ACs using this. And then I keep the walls very clean, no thermostats. Also, using Zigbee temperature sensors lets you put the sensors where the people are instead of on the wall where thermostats are usually. So there's that one. There's another board. This one is, it's got 1 AC on it, and it's got 1 bathroom sensor, and then it has another one. So again, these are all RS-485, here, 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 and here. And then UART is here and here and here, plus the 2 UARTs that are built into the ESP32. And there's oscillators here and here. So this one is an external board that is in the hood in the kitchen above the cooktop. So that board will send messages for when the buttons are pressed in the hood, and it can also simulate button presses on the hood, the original hood hardware, so I can turn the fan on and off. And it has sensors like the bathroom sensor for temperature, humidity, VOCs, and it also has a gas sensor, so I can tell when the propane is burning, turn the hood on automatically. So then these two are sensors that go outside. So this board has a 24-volt input, and it turns that into 5 volts, and that goes outside to these sensors, which are using optocouplers to protect my board from the wires that are going outside. These sensors are time-of-flight sensors. They give me a beam across the staircase at the top and bottom, so I know when someone has entered the stairs, and I can do animations on the LED strips that are in the stairs. It's not as good as the one inside because I don't have 4 sensors, but it'll still be pretty nice to know when someone's on the staircase. And then there's some more connections. Besides 24 volts, we have one more reed switch that didn't make it on the previous board, so it got put here, which is closer to the switch anyway. And then it has a hub connection. So this is to a Unifi Access Hub. So there's a pin pad on the exterior of the house, and if you put in a correct pin, it gives 12 volts to this, which goes through an optocoupler and lets the ESP32 know, which lets my computer know, and that lets me know that someone should be granted access to the house. So then these next 2 pins are 24-volt output to motorized door locks. So the computer can turn that on and off and open and close the locks for access. So we have some relays for this part. And I think that covers it. We have another similar board to those two. So this one, it has 2 bath sensors. That makes the total of 4 baths. It's all the baths in the house. And it has 3 ACs. So again, RS-45 optocouplers for decoupling. No optocouplers needed for sensors that are in the house. So these are sent 5 volts, and they turn it into 3.3 volts for the actual board to use. It does have 2 other connectors, 2 other connections. One is for the garage door, so I'll have to hack the garage door switch so that when these contacts are closed, the garage door will open or close. So this can control the garage door, which does have a read sensor connected to the previous board, so I'll know if the garage door is open or closed. And then it also has an access hub, just like the other board on the other side of the house. This can decide if it should open the garage door using a Unifi pin pad. And again, I don't have enough UARTs, so these are UART chips. So what else do we have? This is a pretty complex board. This is for irrigation. So there's 16 relays here. There's only one that's going to be on at any given time, but there's 16 here. This is an IO expander, an ADC. The ADC is because the current that's going, these are AC relays because the sprinklers are a solenoid that's AC. The current that goes through the relays gets passed through this current sensor and then the ADC, so I can know if like the solenoid is activated when it should be. It also has connections for a flow sensor, so I know that the water is flowing, and this is a pulse-based sensor. Then it has a soil sensor, so this gets put out in the middle of the yard so I can validate my evapotranspiration calculations. So that's a way of guessing at how much water is in the soil based on precipitation and evaporation and how much solar radiation there is, and there's some calculations for that. So I make some assumptions about how much water there is so I can determine how much water needs to be sprayed, and then the soil sensor lets me validate that I'm in the right ballpark for those numbers. And then the soil sensor is RS-45, so love it. Have RS-45 everywhere. Optocouplers for decoupling. And then this is 5 volts and 24 volts for various sensors and the flow rate. So the software for this is probably more complicated than the rest of the boards. There's a big capacitor on the back for the full bridge rectifier, which is right here. But this was pretty fun to build. So this next one, there's a rock address marker, and this goes in that rock address marker. So it has a time of flight sensor that puts a beam across the driveway, so I know when a car has entered or a person has crossed that beam. It also has a connection to a radar, which is pretty neat. So this is the radar. This is an ISIS 4001. This thing's cool. It can see 250 meters up to. I don't need it to see that far, but 150 feet or so will be enough. It can detect if an object is moving towards it or away from it, and the speed of the object. So I'll use this to turn the rock address, the LED lights that are in the rock address marker for the address. It'll turn those on and off based on when a car approaches, which is neat. And so that connects here. Quite simple. It just gives it 12 volts thanks to the West 32 having a 12 volt output. And the contacts that it has here they get closed by the radar when it detects approaching or receding motion. And there's some really nice software for this to configure how sensitive it is, things like that. So it's pretty nice. What else we have? This is one of the bathroom sensors. So in this one, since it's a board that gets connected to the ESP32, it doesn't need to talk on the LAN. It just talks to the ESP32, and then the ESP32 forwards the messages onto the computer. So for this one, this is an STM32 So this is the first board where I got to put my own processor on there, the whole thing myself, instead of using a dev board like the WESP32. So that was fun. Again, it's RS45. It has a power section for 3.3 volts, 1.8 volts over here for this VOC sensor, and this is a temperature sensor. So these fins are because I was having some issues. Previously, I tried to use an ESP32C3, and it got really warm and messed up the temperature readings. So now I have 6 inches of traces that go up and down, and I've separated the VOC sensor, which has a heater in it, from the temperature sensor. And then this whole thing goes in a box. I have a custom box like this, which is quite neat. Playing around in SketchUp. So all my boxes are made in SketchUp and then printed at JLC PCB. But it goes in like that. And then this slides in. Oh. Yes, very smooth. Live demo here. It does fit. And then this slides in, and it'll have this part sticking out. And this will get put into the bathroom near the duct somehow. It's to be decided, but it'll be somewhere in the air so that it can do its sensing. All right, here's another one. This is the time of flight sensor. So this one is an amazing sensor. It can see like 30 meters, 100 something feet. Again, it's an STM32. So similar design to the last bathroom sensor, except for it has this laser. This little one is the laser, and this is the receiver. So this is the one that goes across the staircase and across the driveway. So it has an enclosure that is going to work for outdoors, or I hope it's going to work, because I made it, and if it doesn't work, I'll be sad. But it's this is Sugru. It's a moldable silicone. So that's how I waterproof that. This is watch glass, and then I threaded it. This is a cable gland, so the cables will be waterproof. When you turn this, the gland closes on the cables. Yeah, this fits inside, and it centers itself. It has a little LED for telling you that it's detected something. So the pipe will go into a rock wall. It'll have a 1.5-inch hole. This is 1.3-inch pipe. It'll go in that and then get wired back to the other boards that I showed. And it'll tell me when someone breaks the beam. So similarly, I have many of these sensors. So this is a similar thing. This is STM32. The board's black, which JLPCB isn't very good at making. Like you see, it has some streaks, but whatever, it's good enough. So these boards are cool. So this is the same laser, but this one is going to go in the ceiling like this, laser shooting down. And it goes where there's some sliding doors. So when you put your hand in front of the laser, which will be right along the stile, the vertical part of the frame of the door, you break the beam, and then the motorized door, sliding door, will open or close based on that. So this one, the RS485, is multi-drop. So it comes here and goes out to the next one. So I have many of these sensors on 2 different RS485 connections, which go to this board. And for some reason, I put all the components on the wrong side of this board. Because when it plugs in, now you can't see the components. Makes it difficult to debug, but it's not worth redoing for that. This is very simple. It's 2 RS485s that have optocouplers. It has a relay, a nice barrel connector for 5-volt input. So I have isolated 5-volt power to all of the lasers. And then I have 7 lasers on this one and 5 lasers on this one, which sounds like a lot, but it's because the doors are staggered, and there's a screen door and a glass door. So in some places I need a laser then the door, and then another laser, and the door that's the screen, and then another laser, depending on which is open or closed, the glass or the screen. I'll activate the different lasers. But it should be neat. So the lasers shoot from the ceiling, and I know the time of flight, so I know the distance to the obstruction. So if the dogs come and the obstruction is near the floor, then I can ignore it. If the obstruction is, higher, like waist or chest high, then I can just open the doors normally, and maybe have an egress mode where it opens and then closes. And if it's up really high, I can do something different. And I can have a gesture where if you block it and then move your hand up, or you block it and move your hand down, I can do something differently. And I've written the code for all that. It works really well. This sensor is amazing. It works in the direct sunlight. So even the lasers for the exterior stairs and driveway, those are going to work in the rain, in the sun. I tested other time of flight sensors. They do not work in the sun at all. So this is pretty great. So this next one, this one is the one for the hood. I'm going to redo it with an STM32. This is a black pill, which is a dev board, and it's soldered on here like an SMD component, which isn't super reliable way to do it. It works. Mostly this board, it gets wired to the hood hardware, and it's a bunch of optocouplers. So some of them are for sending 12 volts out, when some are there for receiving. And then it gets wired back to the other boards for communication via my favorite RS-45. Right there. It has a nice board, or a nice enclosure, which is kind of cool. I like making these enclosures. It's fun. So it fits in like this, and then the lid goes on in a little track. Like that. It's pretty sweet. Then there's magnets on the back, so it can stick inside of the hood somewhere out of the way. Yeah. So what else? There's this one. So the motorized doors, normally you have a big ugly switch that you would put on the wall, but of course we don't want that. We have lasers. So I need some way of controlling the doors themselves, like open and closing. So this connects to 10 motorized doors, which again seems crazy, but you think some of the openings have 2 doors, and then they have screens. So that's 4 doors for just one opening. So it's a lot fewer doors than it might seem. But each of the doors has 24 volts that comes, and 4 wires that, when connected to the 24 volts, will open, close, stop, or lock the door. So I have there's 4 optocouplers in each of these. So it's basically just a bunch of optocouplers. There's 10, and they have 4 each, so that's 40 outputs. So these are I/O expanders to give more pins, and nothing on the back of the board. So this just controls the door, that lets the computer control all the doors. So we're getting close to the end. All of my little toys. This one, grabbing this. This one is an architectural microphone and air sensors and other things. So the microphones are here and here. Those are MEMS microphones, actually, here and here. I made a little board, and then I soldered it on like an SMD component, because I needed the right height. This puts it at just the right height as the other components. You have a bunch of LEDs around the side. Then you have VOC, temperature. This is a LiDAR sensor, and a light sensor, and humidity sensor. So a bunch of air sensors. You also have another board here. This is a CO2 sensor, and this one attaches on the back. But I won't attach it right now because this all goes into this part, which is 3D printed, and slides in like that. So the sensors are exposed to room air through this little slot, 1 millimeter slot. Now the CO2 sensor can go on. Like this. Wow. Bam. So this gets connected back to an ESP32, which looks like this. These 3 Ethernets get connected to the faceplate, and then it gets connected to the LAN. This board, this is a really complicated board. This is my only 6-layer board, and it has an XMOS AI sound processor. So this does beamforming and other fancy stuff with the microphones, and also does audio output. And then this has speakers. This connects to speakers so that I can have the house listen and talk. So mainly it's so that I can have some AI stuff and try to make my own sort of assistant, or tell the computer to open the doors or turn the lights on or off. So this faceplate goes into a drywall flush mount that I printed. Let me grab that. So this is the flush mount, and it's broken because I was doing some strength testing, but it goes in here. This goes in the wall and gets mudded so that there's just this opening in the wall, and there's an Ethernet back there. Then this plugs in here. This whole thing has to fit through here, and the wall has to have enough depth to plug it in here and here, and then drop it in the wall, and then it connects to the faceplate. And then this will be painted to match the wall. So the only thing you'll see will be this slot, and then I'll have microphones around the house, just in the public areas, not in the bedrooms, of course. But that will be neat. Then, oh yeah, the last part is that there's the speaker, which also has to fit through this hole. So you can just fit it and then stand it up and have it drop into place like this. So that's the idea. Hopefully I don't drop this into the wall while I'm trying to do all of this through this tiny little hole. It's easy when you can have your hand behind it. When everything has to go through here, that's going to be quite interesting. But in testing, it does go through just barely. So that's pretty much it. There's a lot of boxes for all of these devices. Yeah, so once it's all put together, then I'll have to do a demo of everything working. So yeah, hopefully this inspires someone to do something similar. It's a lot of fun. It takes a lot of time and effort to figure out how to do all this stuff, but it's really satisfying, and I'm especially happy to have it all done because it's been so long and I've had to remake things so many times. So it's done now, and I can ship it all out, have it installed in the house. It's going to be sweet. One more little bit. Here's everything in the enclosures. So the ESP32s snap in, and then the daughter board just fits on top. Works out really nicely. The AC adapters, they just press fit together. It's very hard to open this again. And also the bathroom sensors are similar. This one's even harder to open. It has vents for cooling it, keeping any heat away from the temperature sensor. And there's a tag connect right there. It's really nice for programming your STM32s. I didn't show on the hood box. It has sensors in the bottom. So the idea will be that there's a hole somewhere in the bottom side of the hood where these can be exposed to the air. And yeah, I think that covers it. And here they are with the lids on.